Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. In this particular paper, we will be solving this P3 paper, that is of October-November 2024, variant 32. It's a walkthrough solution. That means the paper is already solved. So since I'll be explaining every bit of it, so in walkthrough solution, the time that I'll take, that should equal to the time taken by you in the exam. So that should be equal time. Keep that in mind. So now it's 11:59. Let me write 12 noon PM. So let's get started. Question number 1. It says expand this bracket in ascending powers of x. Let me get my highlighter ready. In ascending powers of x up to and including the term in x square, simplifying the coefficients. So everything is clearly outlined over here what we need to do. Now first thing first, let me draw a box over here with the formula that we need. So over here, let me write this thing. This is 1 plus b raised to power of n. That is the first term is 1. And then it's NC1 b raised to power of 1 over 1 factorial, NC2 b raised to power of 2 over 2 factorial, and NC3 b raised to power of 3 over 3 factorial, and so on. But since the power is in a fraction, we have to break up NC1. So let me rewrite the formula again, and this time with the simplified version rather than NC thing. So therefore, this is 1 plus b raised to power of n, that is 1. This is nb power 1 over 1 factorial. So n over 1 factorial is nc1. n minus 1 over 2 factorial, b raised to power of 2. And then n minus 1, n minus 2 over 3 factorial, b raised to power of 3, and so on. Now it's necessary that the first term should be 1. So take 9 common. This power of half applies on the 9 as well as on this bracket. Square root of 9 is 3. This bracket is expanded. So therefore, look at the working. 1. This is n. This is b power 1. So if you want me to, I'll write power 1 over 1 factorial, but it will have no effect as such. And then n minus 1, b raised to power of 2 over 2 factorial. That is multiplication by 1 over 2 factorial. And we just need the first 3 terms, simplify, multiply, you get the answer. That's how easy it is to obtain 4 marks. Question number 2, let's get started. By sketching a suitable pair of graphs, show that the equation has exactly one root in this interval. Now first of all, look at the interval. 0 is not included, pi by 2 is not included. That means there is an asymptote over here, there is an asymptote over here. Y is equals to tangent kx. Why am I talking about tangent? Because cot is the reciprocal of tangent. Y is equals to tangent kx. The rule is 2k cycles in 360. Y is equals to tangent 2x. Value of k is 2. 2 into 2 is 4. 4 cycles in 360. Therefore, in 90 degree, 1 cycle. So this red one, that is the graph of y is equals to cot 2x. So I have worked with tangent, but I know I have to draw cot. So this is y is equals to cot 2x. And then over here, sec is the reciprocal. So let me get the green marker ready. So sec is the reciprocal of cosine. So this is about cosine. What's in cosine? Y is equals to cos x, 1 cycle in 360. Therefore, in 90 degrees, it's 1/4 of the cycle. So when we draw cos, cos goes like this, and sec over here goes like this, and there is this asymptote. So the green one over here, that is y is equals to sec x. How many points of intersection? 1. Therefore, there is one solution. Pretty basic, huh? So now the next one. Show that if a sequence of real values given by the iterative formula converges, then it converges to the root of the equation in part A. That means either show that the equation becomes the IT formula or the IT formula gets converted to the equation. There are 2 ways of writing it. This is the original equation, that's right over here. This is the iterative formula, equation to iterative formula. Cot 2x is sec x, cot is 1 over tan, sec is 1 over cos. In other words, tangent 2x is cos x. Therefore, 2x is tan inverse cos x. Of course, there were many different ways of breaking this up, but look at this. They're talking about tan inverse. That means we have to work with tangent 2x. So 2x is tan inverse cos x. Therefore, x is half of tan inverse cos x. That's one way. Alternatively, if I have the iterative formula, what I can do is that after successful iteration, the input and the output becomes the same. So this is your input, this is your output. After successful iteration, it becomes the same. Cross multiply and then you get the answer. So there were only two parts in this particular question. There was no iteration as such. Numerical solution was there, but no iteration as such. Now let's talk about this third question. That is question number 3. It says the square root of 6 minus 8i can be expressed in the Cartesian form x plus iy, where x and y are real. That is always a condition and exact. So now over here they are focusing on exact. By first forming a quartic equation, a power 4 equation, find the square roots in the exact Cartesian form, and they are saying it could be in terms of x, it could be in terms of y. So now what's the very first step? The very first step is let the square root of this thing is this thing. Square both sides. When you square both sides, this is a plus b whole square, a square 2ab plus b square, I square is -1, that is -y square. So therefore, this is the real part, this is the imaginary part. Now, if two complex numbers are equal, the real should equal the real, the imaginary should equal imaginary. This is the imaginary, this is the imaginary, that is equation number 1. Therefore, make y the subject. I could have made x the subject also. I prefer making y the subject. The second thing, the real part equals the real part. So therefore, that's right over here. That is equation number 2. You plug it in, you square, you cross multiply. That is your quartic equation. So don't do the substitution from before. First make it quartic equation, then do the substitution. Let m is equals to x square. Therefore, m square is x power 4. You get this thing. That is easily done by middle term factorization. We are getting two answers. X square is 8, x square is -2. If we use this, then x won't be real. But we need x and y to be real. That is the reason for discarding it. So therefore, x square is 8. Therefore, x is root 8. I can also write root 8 as 4 into 2, which is root 4 root 2, which is 2 root 2. So I can also write it this way. I have done the simplification later. Also remember, y is -4 over x. I plug it in over here, I rationalize, I get this value of x, I get this value of x, and over here this is y, my bad. Let me do my correction over here. So therefore, I was working for y, this is y, this is y, this is y, and so on. So therefore, this is square root 1. This is SQ1, this is SQ2. These are the two answers. They are not conjugates of one another. That is some extra information. So 3 questions are down. Let's look at question number 4. Question number 4, it says, solve the equation, give your answer correct to 3 decimal places. These are favorite examination questions. You can take ln or lg from the beginning. I prefer to simplify first, or make a substitution. Let y is equals to 5 power x. So I broke this up. This is 5 power x into 5 power 2. That is for this thing. And then transfer all the y's on one side. I substitute, and then I make y the subject. But what is y equals to? 5 power x. So now you take ln or lg of both sides, doesn't make a difference. And then you find this answer correct to 3 significant figures. That is the basic working for question 4. Question 5. Now this question, I have done it in 3 different ways. So this first part, actually I'm talking about the very first part, I have done in 3 different ways. So this is method number 1. Let me write it in black pen. Method number 1. Let's look at the method. It says u is cosine 1 over 7 pi plus I sine 1 over 7 pi. And over here, I think one of the method I've repeated it, so no issue. So it says this top thing, that is z, cosine of pi by 7 plus I sine pi by 7. And this one is cosine of pi by 7 minus I sine pi by 7. Now, I am claiming that this thing is z star. Now, why am I making this claim? I'm making this claim because cosine of negative theta is cosine theta. Sine of negative theta is minus sine theta. Now, when we talk about this modulus argument form, we don't see a minus over here. We always see a plus, and the sign of the angle changes. So basically, if I have cos of minus theta plus I sine minus theta, that will be simplified to this. So basically, this thing is what? This thing is originally, let me write this thing, z star is cosine of negative pi by 7 plus I sine negative pi by 7, which actually simplifies to this. Got the idea? So that is z star. So argument of z4, it's 4 times argument of z. Argument of z star is minus pi over 7. How? That is the logic explained over here. Argument z4 over z star, it's argument of z4 minus argument of z star. That comes out to be 5 pi by 7. Let me first explain part B, and then I'll move to the other two methods once again. Now over here, it says the complex number u and u star are plotted on an Argand diagram. Describe the single geometrical transformation that maps u onto u star and state the exact value of argument of u star. So that is already done. If we have u is this thing, argument of u is this thing, what we are doing over here. So this is basically argument of u is this thing. So that is equals to this, that is equals to this. So argument of u, this is 5 pi by 7. Therefore, argument of u star is negative 5 pi by 7. What are they of each other? Reflection in x-axis. So remember, if we have a complex number drawn on an Argand diagram, so now there is one thing over here, the other one is over here, the conjugates, they are reflection of each other in the x-axis. This is the x-axis, this is, let's say, one z, and this is the other one is z star. Wherever the quadrants are, doesn't make a difference, they are reflection of each other in x-axis. Now, alternative way, that is method number 2. Let me write it over here. So now this is method number 2. How have I solved this particular method? Now what I did is that I used the concept of rationalization. So because it was a scenario of division, rationalization, so what have I done? So look at this thing. Let me just use the red marker. There is a negative sign. This is positive. This is positive. This was negative. So that is how you rationalize. Multiply and divide by conjugate of denominator. So now over here, when we look at this, this has a power of 4. This has a power of 1. So this becomes power 5. At the bottom, this is a minus bi, a plus bi. So let me write it over here. So when we have this thing, a plus bi into a minus bi, that becomes a square plus b square. So now focus over here. Let me use a blue marker over here. So this is a, this is minus bi, this is a, this is plus bi. Therefore, this is a square plus b square. This is a square, this is b square with a positive sign. Now, how does it become 1? Again, another piece of knowledge that people forget, that is sine square theta plus cos square theta equals to 1. Doesn't make a difference what this theta is. As long as these two angles are the same, the squares of the individual trig ratios will add up to 1. Sine square plus cos square is 1. So therefore, this is cos square pi by 7. Sine square pi by 7. Therefore, it equals to 1. So we are getting this thing. Once we get this thing, let's move over here. So this is u, and this is argument of u. That is written over here. So let's not write u or, okay, because u they have already used. So let me write another thing. Let me write a w. W equals to this. Argument of w is this. Therefore, w to the power 5 is this thing, power 5. Argument would be 5 pi by 7. Got the idea? So this is argument of u power 5. Therefore, that is what we are looking for. So that was another way. And part 3, I think I did not deliberately, coincidentally forgot to look at that part. So that is like this. So it's the same thing but just written with symbols. So it's slightly twisted. So this is method 1, little bit modified. And I think it's the same thing. I focus on the denominator, then I wrote it like this. Then I said let W is this, W star is this, and then I denoted this by theta. Theta is pi by 7, this is negative theta. I worked in terms of theta, then I plugged it in. So I think it's the same thing as this, except I was working with numbers. Over here I worked with a little bit with symbols. So now question number 6. Question number 6, what is it about? Question number 6 is about linear law. And after 6, I'll note down the timing, how much timing is left. So now over here, this is your line that's going like this. There is this point, there is this point. The first step is coordinate geometry. Find the gradient. You can leave the answer in exact form, convert it into decimals. Y is equals to mx plus c. First plug in m, then plug in x, then plug in y, find c. That is basic coordinate geometry. And then the next part is this, that is about logarithm. And which logarithm? Natural log. So ln of ay, that is ln b raised to power of x. Multiplication becomes addition. Power comes down and multiplies. Make ln y the subject, x ln b minus ln a. Now focus on this. ln b is your gradient, your x is your x, and your constant all alone is your y-intercept. So therefore, that is how the working is done. Let me change it all to black so that I'll use the color now. Hold for a second. So color is all black. Okay. So now over here, when I talk about the red stuff, that is the gradient. So let me first focus on this. M equals to ln b. That is the value of m. That's right over here. ln b is this. B is e raised to power of this, and then the answer correct to one significant figure, because that is what they have asked. Similarly, if I look at the green thing, c is negative ln a. C is negative ln a. So therefore, negative ln a is this value of c. That's right over here. Ln a is this thing. A is e raised to power of this thing. Therefore, a comes out to be 0.3. So it's a combination of logs and coordinate geometry. Question number 7. What is it about? This is about trigonometry. But before this, let me just wait over here and let me draw a box right at this instant. And that is the first 6 questions. So question number 1 till question number 6, we started at 12. This is 12:16. I think that was pretty fast. So let me give you another 10 minutes. So that means for 25 minutes, you should be able to solve this thing. Because like for example, in this one, I did not use the calculator. So of course, time will be spent over there. Over here, I more or less did 3 kinds of working. So time was never an issue. Over here, just use a calculator at this point. So I gave you 10 minutes extra. So therefore, from your perspective, 25 minutes for these questions are perfect. Now, where is it? Question number 7. Let's get started. And we are now starting at 12:17. So this is, I'm starting at 12:17, and then I'll add some extra minutes if needed. Figure shows, not the figure, show that the equation may be expressed in this form. So first thing you should notice, there is x, there is 2x, there is x, therefore double angle has to be used. So double angle of tangent, I wrote it. Also, I wrote this thing for convenience, that is let tangent x is equals to t. So that I don't have to write a lot of English on it. So therefore over here, tan cube becomes t cube. 2 remains as 2. Tangent 2x, 2t over 1 minus t square. 2t over 1 minus t square. Minus tangent x minus t equals to 0. That's the first part. Second part is multiplication by 1 minus t square. It's multiplying, it's multiplying. Simplify. We get what? We get t power 5, t power 3, t. Take negative and t common out. So whatever I am left on the inside, that is what I wrote it back in the original English format. That's quite easily done. and minus t equals to 0, t is equals to 0. I reject it. Why did I reject? Because for tan x does not equal to 0. So when you are taking common, that should be the first priority. But why are we discarding it? Because the examiner says so. The second part. Now it says, hence solve this equation, give your answer. So now we have already done part A. We have already proven, we have already have this particular equation. Let m is equals to tan square. Therefore, m square is tan power 4. So now this is the second time we are getting a disguised quadratic equation. The first one was in complex number. So we have this equation, we do middle term factorization, realize this thing, how important is middle term factorization. And examiners are interested in seeing the whole process. Show all essential working, no compromise on this. Show all essential working. That thing is done. We are getting one answer, m is -1, but m is equals to this thing. So m equals to this thing. Remember, let me write over here, m is equals to tan square 2 theta. Keep that in mind. So you cannot take square root of a negative number except in complex numbers. So discard this thing. So this is discarded. That thing is done. And then the other thing that is right over here, m is equals to plus 3. So therefore tan square 2 theta is plus minus 3. It's plus 3 first of all, my bad. And then when you take the square root, that's plus minus 3. So answer in all 4 quadrants. Theta lies between 0 and pi, not inclusive. 2 theta lies between 0 and 2 pi. Let alpha be the basic angle. Alpha comes out to be pi by 3. So does it say give the answer in the exact form? Yes, it says so. Even if it did not, I would have worked in exact form because of this beautiful angle 60 degrees, which is pi by 3 in radians. First quadrant, second quadrant, theta minus pi minus the basic angle. Third quadrant, pi plus the basic angle. Fourth quadrant, 2 pi minus basic angle. Make theta the subject by dividing by 2. That's the answer. Question number 8. This time it's about parametric. So now let me use a black marker and write parametric equations. Sometimes it's parametric, sometimes it's maxima minima, sometimes it's implicit. Now the parametric equation of a curve are such and such. Theta t lies between 0 and pi by 4. Sometimes they use theta, sometimes they use t. First part, show that dy by dx is this much. I think that was straightforward. So now let me get started. That is x. So this is x, this is dx by dt. Similarly, this is y, this is y, this is dy by dt. Over here, chain rule was used. Tan square 2t is tan 2t whole square. Power comes down, bracket remains as it is, power reduces by 1. Don't forget, multiply by derivative of bracket. Cosine 2 theta, that is basic differentiation. And then we are interested in dy by dx according to chain rule. That is dy by dt, the blue one at the top, the blue one at the top, the dx by dt at the bottom. So therefore the red one at the bottom, the red one at the bottom. And then you can see the simplification that I've done. This sign of division remained intact for 2 steps. I first simplified comfortably. Tangent 2t, sine over cos. Sec square 2t, 1 over cos square. Look at this working, things cancels out, we are left with this. So that is for 4 marks. 4 marks means tough working. Find the equation of normal to the curve at the point where t is pi by 8. Give your answer in the standard form. So now first thing first, dy by dx, the green thing, that is equals to this thing. That is minus half. And this is cos cube 2t, things like that. Plug in x is equals to pi by 8 and you are getting this thing. You can simplify it later also. Now keep in mind, when t is pi by 8, 2t is pi by 4. Tangent of pi by 4 is 1. Cosine of pi by 4, the unrationalized form, the rationalized form, you can choose as per your convenience. Now over here, x is equals to tan square 2t, that is tangent of pi by 4 square, which comes out to be 1. And similarly, y is equals to cosine of 2t, cosine of pi by 4, that's root 2 over 2. So we have x coordinate, y coordinate, gradient. That is the gradient of the tangent. Therefore, gradient of the normal should be negative reciprocal. Now at this point, I have simplified it. So 8 divided by root 2, I rationalized, I got this thing. Y minus y1 is mx minus x1. That is your m, that is your x, that is your y coordinate, that's y over here. And then you can start with this form, slowly and gradually make things the subject. Y is equals to mx plus c. I did some fraction work on the sidelines. So that is how you do everything. Paper spacing is more than enough. Question number 9. Now it's about vectors. So let's see how tough or easy this vector question is. And I think in this particular paper there were I think 11 questions. So now let me finish 9 and then I'll note down the timing. By the way, we started at 12:17. So question number 9, with respect to the origin, the following position vectors are there. There is OA, there is OB, there is OC, and then we are looking for OD, position vector of OD. Now, what information have they given to us? The information that they have given to us is that DC is 3AB, basic O-level stuff. What is DC? So DC over here, that is OC minus OD. What is AB over here? That's OB minus OA. First I wrote OB, then I wrote OA. I simplified, I multiplied by 3, and I got this thing. Once I achieved this thing, then I took this OD to this side, this to this side, and hence I find the value of OD, which comes out to be this. So OD is found over here. Let me use that purple thing over here. So this is OD 3, negative 11, negative 10. The diagonals of the trapezium intersected point P. The name says it all. The name says it all. So now if you have this thing, you have the first and the third, that is AC. You have the second and the fourth, that is BD. These are the two diagonals. So for AC, find AC, OC minus OA. For BD, you can find BD, DB, AC, CA, doesn't make a difference. I found DB, OB minus OD. So now we have AC, now we have DB. So this is AC, this is DB over here. So again, let me do some highlighting. This is DB, this is AC. Now equation of line. So we have R is equals to fixed point plus lambda direction vector. So this AC becomes direction vector of AC. This DB is direction vector of line DB passing through D and B. So this is direction vector, this is direction vector, fixed position vector. I have used OC over here. Doesn't make a difference. I have used OC over here as a fixed point. Over here, I have used OB over here. Doesn't make a difference. So now I have the equation. I have already expanded over here. I have the equation. They are finding the position vector of the point of intersection. So now for that, open up the bracket in terms of lambda. Open up the bracket in terms of mu. Now the x coordinate equals the x coordinate. That is the first equation. The y coordinate equals the y coordinate, that is the second equation. Solve it simultaneously, we get the value of lambda, we get the value of mu. Now there is no need of the third equation, only use third equation. Let me write over here, only use equation 3 if we are asked to prove either two things, lines intersect or lines are skew. If lines intersect, they will satisfy all three equations. If lines skew, so it would be inconsistent, won't satisfy. Got the idea? So now no need to use equation 3 as the reasoning is already over here. Place lambda where it belongs. So lambda belongs in this equation. That is the position vector. I have labeled it as OP. I get 3/4, 1/4 minus 7/4. I can even write it in the IJK form. They have not mentioned anything as such. Now it says use a scalar product. So let me get my highlighter ready. Use a scalar product, calculate the angle ABC. Now they don't want us to use cosine rule. Otherwise we could have calculated AB, BC, AC, magnitudes and then use cosine rule, but they want us to use scalar product. So now the rule is when the name is mentioned, take two vectors diverging from angle point, the point where the angle is made, or you can also take two vectors converging to angle point. So this is the angle point. I took two vectors like this. BA, I think I found it earlier somewhere over here. Yeah, there is AB. I just changed the sign. Similarly, I found BC, which is OC minus OB. Magnitude of BA right over here. Magnitude of BC right over here. So now let me write one more step. That is BA dot product with BC. That is magnitude of BA, magnitude of BC cosine theta, where theta is the angle between the two. So now multiply the x coordinate with the x coordinate, multiply the y with the y, that's right over here, multiply the z with the z coordinate, add it all up. This comes out to be how much? This comes out to be 8. And then the bottom line, we already have root 29, that's right over here, root 46, that's right over here, and then it's right over here. Now use a calculator, cosine inverse of this, and this final answer is coming out to be 77.3 degrees, correct to one decimal place. They did not specify degrees or radians. I prefer degrees. So now this is 12:30. I think maybe I'm speaking too fast. Let me know in the comment section. So now we started at 12:17 and now this is 12:30. So we did question number 9, that is of vectors, question number 8, that is of parametric, question number 7, that is of trig. So to be realistic, let me add 15 minutes. So this is 13 minutes. Let me add 15 minutes. So therefore, that is 28 minutes for you guys to try out questions 7, 8, and 9. 3 questions, 28 minutes. And before that, how much was the time taken? That was over here, 25 minutes. First 6 questions, 25 minutes. Let me go to the last page and write it all down. So over here, first 6 questions, let me draw 3 thick lines. That is the first one, that is the second one, that is the third one. So questions 1 till 6 inclusive, that is 25 minutes. Question number 7, 8 and 9, that is 28 minutes. And now if we have 2 more questions, 10 and 11, that should be taking this much time. So that is including that extra time that I have given. And I think it should not exceed 1 hour 30 minutes if you have done your practice very, very well. So now let me go back and where were we? The vectors 1 is done. So now we are starting with this question number 10, and question number 10, this is I think differential equations. Yes, this is d phi eq, and the time is 12:32 p.m. Let's see how much time will it take. Now over here, the question is, a balloon in the shape of a sphere has a volume v and radius r. So now we have the volume of a sphere. We can differentiate dv by dr and we will get 4 pi r square. Now it says air is pumped into the balloon at a constant rate of 40 pi. Now from my perspective, or maybe they did it deliberately, that they missed out the units. They should have stated the units. That is the rate at which air is pumped. It's filling up a volume. So naturally this is dv by dt. So this one is dv by dt. And before that, what I did was dv by dr. Got it? At the same time, air begins to flow out at a rate of this much. So 40 pi is constant. So 40 pi is constant. 0.8 pi r has a r. That means it has a variable. And that is how this is written. This is the overall, the net rate of flow. Now it says show that R and T satisfy this differential equation. So now I am interested in this third part. Show that R and T satisfy this differential equation. dr by dt is this much. And this is for 3 marks. So now by now you have realized that this is about rates of change. So it's about this thing. dr by dt is over here. And then dv by dt is over here. That is dv by dt. And dv by dr is over here. So v, r, t, that's how they are related. Make dr by dt the subject. That's the first thing. dv by dt, it's right over here. dv by dt, it's right over here. That goes over here. I took pi common out. And dv by dr, 4 pi r square, that's right over here. So this pi and the pi cancels out. So now 0.8, I have written 0.8 as 4/5. Okay. Then I took LCM, 5 into 40, 200 minus 4 divided by 5. So this is 200 minus 4r divided by 5. That 5 goes down and multiplies with this 4, making it 20. So now this is all O-level math stuff. And then what I do is that I divide by 4. So 20 divided by 4 is 5, 200 divided by 4 is 40, 4r over 4 is r. This is what I'm getting. And this is 50 minus r over 5r square. That is how you have to prove this. So this is dr by dt, and that is the green color thing that is needed over here. Got it? Now this is giving you extra support. Find the quotient and remainder when 5r square is divided by 50 minus r. So 5r square has a power of 2, 50 minus r or minus r plus 50 has a power of 1. So 2 steps will be there, minimum. So now over here, maximum, not minimum, maximum, because the power difference is this thing. First, r square will give me a denominator in terms of r, and then I'll get a constant. As soon as I get a constant, I'll stop. 5r square over negative 5r, multiply with each, change the sign and add. So you get 250r. 250r over minus r, negative 250. And then this is the remainder. So quotient minus 5r minus 250. Remainder 12,500. Divisor is already there. So divisor was already there, which is 50 minus r. So how do you write it? Quotient plus remainder over divisor. So quotient is minus 5r minus 250. Let me just shift this thing a little bit over here. The other eraser, the stroke one. Okay. So this is minus 5r minus 250 plus 12,500 over 50 minus r. So they were just asking for quotient and remainder. So quotient is there, remainder is there. Basically, this is what they have asked for. Okay. Now the next part. Solve the differential equation in part A. Solve the differential equation obtaining an expression for t in terms of r. So that's the differential equation. Now since I need t the subject, I can flip both the fractions. Therefore, that is what I have done. dt over dr is this much. Now dt on the left hand side, all the r terms with the dr on the right hand side. Now integrate both sides with respect to the corresponding variables. There is a constant 1, it becomes t. 12,500 over 50 minus r, that is a remainder, quotient, remainder, divisor. ln is used. So now let me focus on this negative sign. 1 over negative 1, 12,500 as it is, ln of this thing. And then this thing over here, let me get a blue marker ready, minus 5r, that is minus 5r square over 2. And minus 250, that becomes minus 250r. And this constant of integration is there. So now plug in the value, which is over here, which is this thing. When t is 0, r is 0, simplify, c is 12,500 over ln 50, not over, into ln 50. Now therefore t is this thing, that is already the subject, all done, all dusted. Now part D, I think this is part A was this, the proving, part B was simplification, part C was differential equation, that is for 6 marks. And part D, find the value of t when the radius of the balloon is this much. So let me highlight this thing over here. Find the value when the radius of the balloon is this much, that is this part over here. So the working for D is down below. So therefore R is 12, find T, plug the value of T over here, and let me just highlight, this is T, this is T, this is T. Just use a calculator, T comes out to be 70.5. Question number 11, I think this is the last question. It looks like differentiation, that is for sure, and integration. So it's a perfect ending to this paper, differentiation and integration. Now it says, let fx equals to this thing, find f prime x, hence find the exact coordinates of the stationary points on the curve. When it says exact coordinates, that means the x coordinate and the y coordinate. We need both of them. Stationary point, dy by dx equals to 0. And how would we differentiate? This is u, this is u prime, this is v, this is v prime. This is quotient rule. So therefore, as a reminder, let me write d by dx of u over v, v u prime minus u v prime over v square. So we start from here like this. So this is v, this is u prime. There is a negative sign, that is u, and this is v prime. Got it? So v, I think the position is changed. This is v, this is u prime. And then divide by v square, this is v square. Now look at all the working. First take common, that is the first and foremost responsibility that we should always take common. Simplify on the inside. Denominator as it is with the square, I wrote it later over here. And that's it. You don't need to expand it. Don't even think about expanding it. Why would you mess it all up? And then it says f prime x equals to 0. So therefore this thing equals to 0. No solution. E raised to any power can never be 0. And then over here 4 minus 3 ex equals to 0. X is ln 4/3. Now once x is found, now find the y coordinate. So that is the x coordinate, that is the y coordinate, and over here this is necessary. E raised to power of ln x is x provided x is greater than 0. E raised to power of ln 4/3 is 4/3. E raised to power of 2 ln 4/3, 2 becomes the power. So 4 after squaring becomes 16. 3 after squaring becomes 9. So therefore e raised to power of ln 16 over 9 is 16 over 9. And then this is e raised to power of 2x, that is 16 over 9. E raised to power of 2x, that is 16 over 9. E raised to power of x is 4/3. The rest is all basic fractions. You get negative 16. Therefore the exact coordinates of the stationary point is this. So that was a nice question. Let's move on. And now it says use the substitution. 9 marks, that's a lot. This is 5, this is 9. Use the substitution. U is equals to e power x and partial fractions to find the exact value of this integral between these two limits. Give your answer in the form ln a, where a is a rational number in its simplest form. That means it will be a fraction of 2 integers. Now let's get started with all the steps. Now first thing first, that is u is e raised to power of x, therefore du is this thing. That is the first thing. So this is du. I broke this e raised to power of 2x, so I broke this thing into ex and ex like this. So ex dx becomes du. The next thing, u square is e power x whole square, so therefore over here u square is e raised to power of 2x. Let me shade this thing in blue color. So that is e raised to power of 2x, that is this thing. E raised to power of x is u, that is the red thing. E to the power x, that is u. And what else is there? The limits, that will come up later. So now e raised to power of x dx, that is du. And this one is u. Hold for a second. This one is u. And then this one is u. This one is what? That is u square. And now it's all algebra. So exponential turned into algebra. Now what's the next stuff? Now, middle term breaking, this is what you're getting. Now over here, this is the partial fraction thing. So let me just draw a few lines over here. Purple color. This thing is over here. This thing is the partial fraction thing. So again, you have to show the working. Of course, this is not rough working. This is on the sidelines. So therefore, this is a proper fraction. And this is a case of linear factors. So this is linear factors. And then you get two constants. So first of all, I got a as -2. So that is a over here. That is -2. This is negative and this is 2. And I got b over here. That is 4. b over here. That is 4. Got it? And then once you have done this, no wonder they are giving you 9 marks for this. Now integrate. The coefficient is 1. The coefficient is 1. 1 over 1. 1 over 1. 4 as it is. 2 as it is. Negative as it is. ln of u minus 2. So now let me use the original color. This u minus 2 integral is ln u minus 2 with this one. And over here u minus 1. This is 1 over 1 ln u minus 1. And then the limits. Yes, the limits. Don't forget the limits. So over here, this is for the limits. Again, we are using the same technique as before. X is ln 3, u is e raised to power of ln 3, which is 3. X is ln 5, u is e raised to power of ln 5, which is 5. So therefore, ln 3 becomes 3, ln 5 becomes 5. Plug in the values, simplify, every working is shown, ln of 1 is 0. And then you are getting this answer, which is right over here, ln 81 over 4. This is a rational because it's a what you call quotient, a fraction involving two integers. The numerator is the integer, denominator is an integer, and it's an exact form. So now we started, I think, at 1232, if I'm not mistaken. So we started at 1232, and this is 1246. So 1232 till 46, that's like 15 minutes. Add 15 more minutes. So 15 plus 15, that is, or 15 plus 10, I think. Okay, let me give even 30 minutes. What difference would it make? So this is like lesser than 90 minutes. That is what I proposed. Should not exceed this much. So now if I can do all the explanation in this time, definitely you have the courage and the stamina and the expertise to finish this paper off. So that is October, November 2024. Very nice paper, variant 32, all done and dusted, and more papers on the way. Stay tuned for more content on Mathematics with Shahab Yaqub.